Okay, today we are going to start Module 20, which is about zeros, solutions, roots, and the zero product property. So our first explain, we are going to use the idea of zeros to solve a quadratic equation graphically. This whole section is dealing with the introduction of finding solutions to our quadratic equations. The solutions are important because if you model a quadratic equation, one good example is throwing a ball. If you throw a ball in the air, it's going to make that parabolic shape. Finding the zero or the roots or the solutions to this will tell us important things like when the ball lands, how long it takes to land, or how far the ball will travel when you throw it. So these are important things to find when we're modeling situations using a quadratic equation. So one thing to keep in mind, we will have multiple things that all mean the same thing. A zero, a solution, or a root all essentially mean the same thing. And when we're dealing with a quadratic equation, the zero is what makes the value of the function zero for that particular x value. So these are essentially the x-intercepts of the graph. So we can have one solution, we can have two solutions, or we can have no solution. So it can hit the x-axis one time, two times, or it can't hit at all. So we are going to, using the skills we already learned, graph equations, and then find the x-intercepts, which will be the zeros. Okay, our first example, 2x squared minus 5 equals negative 3. Well, first we want to rearrange that equation so we get everything on one side. So we add 3 to both sides. All right, and that's where we get the 2x squared minus 2 equals 0. We want to find when that equation equals 0. That's the related function is y equals 2x squared minus 2. So we're essentially, when y is equal to 0 is the solution or the root. Okay. We make our table. You guys know how to do this. You plug in x and y values and make a quick graph. For this, we have our table, we have our graph, plugged in the numbers 0, 1, 2, negative 1, and negative 2. So the zeros are where it hits. They are right there, where it hits that x-axis. So when x is equal to 1, it hit y is equal to 0. When x is equal to negative 1, y is equal to 0. You can also sometimes find them directly in the table. All right, so the solutions are x equals negative 1 and x equals 1. Example 2. We want to rearrange this so it's in a form that's a little better. So we're going to add x squared to both sides. So we get x squared plus 6x plus 8 equals 0. All right, so the related function, because we want to find when y is equal to 0, so y equals x squared plus 6x plus 8. So these values are given to you in this table to make it a little easier. We would have to find the vertex, and then we could start there. We haven't talked really how to find the vertex in this type of quadratic equation, so these tables will be given to you. All right, we make our table. We're going to then fill in our points. So negative 5 squared plus 6 times negative 5 plus 8. So 25 minus 30 plus 8 is 3. Do the same thing for negative 4. Negative 4 squared plus 6 times negative 4 plus 8. So 16 minus 24 is negative 8, plus 8 makes that 0. Put in negative 3. Negative 3 squared plus 6 times negative 3 plus 8. And 9 minus 18 is negative 9, plus 8 makes negative 1. Now, I'm going to tell you right now, this is the vertex, and by symmetry, this will be 0 and this one will be 3, but you could plug those numbers in, negative 2 in, and find it that way. So let's graph these, negative 3 and negative 1. Negative 4 and 0, negative 2 and 0, and negative 1 and 3, and negative 5 and 3. So the graph should look something like this. The zeros are going to be negative 4 and negative 2. All right, so the zeros, negative 4 and negative 2. So we would write that as x equals negative 4 and x equals negative 2. All right, on this year, okay, I'm going to get you guys started on this one a little bit. We're going to add, first we're going to add 3 to both sides of the equation. All right, and so we end up getting x squared minus 1 equals 0. So what I'm going to do is I'm going to write the associated equation. This is the same as y is equal to x squared minus 1. So let's make a table of that. And for the xy values, I'm going to kind of give them to you to help you out a little bit. Okay, I know from looking at this graph how it's related to the parent function is that minus 1 on the end just moves it down 1. So I know my vertex is going to be at 0, negative 1. So I want you to find the values for 1 and 2 and negative 1 and negative 2. Plug them in, then you can graph it and find the zeros. So pause it, try it, and then we'll go over it in a second. All right, so if I put 1 in, 1 squared is 1, 1 minus 1 is 0, 2 squared minus 1, 2 squared is 4, minus 1 is 3, negative 1 squared is 1, minus 1 is 0, and negative 2 squared is 4, minus 1 is 3. So we can graph this. We have 0, negative 1. We have 1 and 0, and negative 1 and 0, and we have 2 and 3, and negative 2 and 3. So it should look something like that when we go to graph it. Okay, the zeros are where it hits right here. So the zeros for this one, or the solutions or the roots, are at x equals negative 1 and x equals 1. Okay, so another example of if you have where you would have something that is not necessarily two solutions, if we had this quadratic right here, where the vertex hits at x equals 2, that's the only spot where that graph would hit that line. So this would have one solution. All right, so that's one example. Another example, if we have something that has no solutions, if we have a quadratic that the graph looks like this, if it never hits that x-axis, this would have no solutions. All right, so there's no value of x where y is equal to 0. So those are the other two possibilities that you could see. All right. The majority of the time you'll end up having two solutions though. Our next topic in this section is going to be the zero product property. So this is going to be helpful when we go to solve equations. That makes it a little easier because we won't have to graph it all the time. We're not always going to have a graph, and this is another way to approach those quadratic equations. So first off, we need to understand what the zero product property is. So it's for any real number a and b, if you multiply them together and it equals 0, then one of the numbers has to be 0. So the idea of 9 times 0 equals 0, and 0 times 4, that would be 0. So the only thing that would work in that case is a 0. The only thing that works as the answer there is 0. So if a times b is equal to 0, then a equals 0 or b equals 0. We can use this idea to find solutions for a quadratic equation if it's in this form. We call this factored form. Our next lesson, we are going to learn how to get to factored form and find solutions this way. All right, so the idea is we are going to find functions that we're going to find zeros in a quadratic that takes this form. All right, if you remember, we know this is going to be a quadratic because if we have x plus 1 and x plus 2, for example, if we extended that out, we'd get x squared plus x, 2x, and 2 times 1 is 2. So this is the same as x squared plus 3x plus 2. It is a quadratic because it has an x squared as its highest term. So in this, if we have it in this form, in the factored form already, when we want to find where either of this makes it 0, we use this idea of setting it equal to 0, and then we want those things to equal 0 when we multiply them together. To do that, if I have 0 times x plus 7, that would equal 0. Also, if I have x minus 15 times 0, that also equals 0. Okay, so these are the two situations where I could get this to equal to 0. So what I'm going to do is set each part equal to 0, solve for x, in this case add 15 to both sides, and I get x equals 15. In this case, subtract 7 from both sides, and I can find out what value of x would make this whole equation 0. Okay, so the solutions, or the zeros for this equation, are where x equals 15 or x equals negative 7. All right, because if you plugged one of those two things in, it would make the whole multiplication equal to 0. All right, second example. We want to set these two things multiplied together equal to 0. It will be equal to 0 when x plus 1 equals 0, or when x plus 23 equals 0. All right, so in this case, subtract 1 from both sides. So x equals negative 1. In this case, subtract 23 from both sides. X equals negative 23. So the zeros are negative 1 and negative 23. All right, this process is a little bit quicker than graphing it and trying to find zeros that way. All right, to your turns, go ahead and try them. I'll have examples for them or solutions in just a second. Okay, so we're going to rewrite the equation so that it's equal to 0. X minus 10 times x minus 6. When is that equal to 0? Well, it's equal to 0 when x minus 10 is 0 or x minus 6 is 0. Okay, add 10 to both sides here. So x equals 10 or x equals 6 when I add 6 to both sides. So my solutions to the first one are 10 or 6. My roots, my zeros, or solutions, you'll see all of those different terms. All right, and the second one. Now, when we write it as equal to 0, if we divide by 7 on both sides, that'll go away. And then I can write x minus 13 times x plus 12 is equal to 0. So the zero product property, if x minus 13 is 0, then the whole thing is 0 because it's multiplied by 0. So add 13 to both sides. X equals 13. Minus 12 from both sides. X equals negative 12. So those are my two solutions, or two zeros. One thing you'll notice, the zeros are the opposite of the number that's in parentheses. So if it's minus 10, the 0 was positive 10. If it was plus 12, the 0 was minus 12. All right, you have a couple practice problems, so work on those, and we'll see you next week.